Hello, everyone. Welcome to Backyard Musings, broadcasting live from Apple Valley. I'm Steve.
I'm Scott.
Thank you for joining us today. Interesting science segment today. A tractor beam from MIT uses light on cells to make sci-fi for reals. A breakthrough technology from scientists at MIT has made it possible to manipulate particles in what has been referred to as reminiscent of the tractor beam in Star Wars and Star Trek.
Very
Fascinating.
Cool. Yep, very cool.
When I first started reading that, I was like, what? The microchip contains multiple optical traps that work to focus beams of light that isolate biological particles and control their movements, opening up the possibility for cells and DNA particles to be controlled. Okay, so medical for now.
Yeah.
Okay. Developers are hopeful that the chip-based technology will give a more compact, affordable, and versatile solution for treating diseases like cancer.
That would be awesome.
And it could blow open the computer industry too. Is this also the start of beaming technology? Beam me up, Scotty?
Yeah. I mean, I don't know how much money they're spending on this thing, but think about all the money that we've spent on cancer research.
Yeah.
And if this thing
can isolate,
that would just be.
And then they talk about tweezers later on, where they,
and they could start putting some of those funds and technology to other things. So that's great. So once the cells are trapped inside the tractor beam, the tweezers can be manipulated to move the cells and or particles that have been isolated. The MIT researchers first tried this practice out on polystyrene spheres, where they worked to isolate cancer cells before using the tweezers to capture and manipulate their movements. This is the first time that the silicone photonics based optical tweezers have been able to trap particles over a millimeter scale distance. That's
millimeter tiny.
Yeah, pretty tiny. So this is stated by Jelena Notaros, a researcher who serves as the Robert J. Shulman Career Development Professor in Electrical Engineering and Computer Science.
So, it's cutting edge. I'm liking it. MIT.
You don't think about them much, but they're a smart bunch over there.
Yeah. So the light from the tractor beam is able to penetrate barriers that protect samples from contamination. So that's cool.
Yeah.
Making testing and treatment potentially safer. The light has been proven to have the ability to pass through the glass that shields cells. Well, of course, it's light. This means that the sterility of a sample will not be compromised. The tractor beams don't have to be on the same surface as the cells to work effectively either. The integrated optical phased array, IOPA, as it's called, can trap cells from afar. Notaros claims this ability will really open the doors for technology. I think not only tractor beams in space, but like a beaming technology, if you can move particles.
Interesting. So with the tractor beam's preciseness and its ability to penetrate glass, Notaros is optimistic that the technology will allow researchers to test their work in natural as opposed to synthetic settings. If this comes to fruition, work can be performed in environments that are totally sterile and much less stressful. The compactness also works to the advantage of future researchers. So the tractor beam's ability to work across longer spans allows for an entire lab scale system to be placed on the smallest microchips. So Notaros says this reduces overhead and lowers the barrier of entry for additional work.
Think of those microchip foundries, millions and billions of dollars to make a foundry just to make a new chip.
So I like this person's thinking, right? Trying to keep it, trying to do this research, but keeping the cost down.
I like awesome. The compactness also works to the advantage of future researchers. The tractor beam's ability to work across longer spans. Smallest. I don't think we read that, or I think we did that. So this is fantastic. I think it's heading in the right direction. Whether we see tractor beams like in space from ships, well, it's not tomorrow, but 10 years, 50. Who knows?
Maybe
if we're still here.
Maybe not in my lifetime, but definitely it's coming. So that's really cool. Really cool.
So so we like to do.
Hats off to the people at MIT doing this research. They're doing some good stuff there.
Anyways, thanks for joining us. We love doing these science segments. Occasionally we throw them in. We keep our eyes open.
Yep. You guys take care.
Yep. Have a great day.
Thank you.